Welcome to Precalculus 12D concept on quadratic functions. We are going to solve problems involving a quadratic function's minimum or maximum value. There's only two boxes. I'm going to walk you through this. So what I'm going to do is walk you through the example that's on page 293 of our textbook. So if you want to follow along in your textbook, you are more than welcome to pause the video right now and go grab your textbook. But basically, here's all the information that you need. However, you do need your graphing calculator, so if you don't have your graphing calculator, make sure you go get your graphing calculator. Okay, so here we go. Here's the picture. Let me read it to you, and we'll begin. It says, Figure 2.8 shows that when a football is kicked, the nearest defensive player is 6 feet from the point of impact with the kicker's foot. Okay, so far so good. The height of the punted football, f of x, it's a function, in feet can be modeled by the following quadratic. F of x is negative 0.01 x squared plus a 1.18x plus 2. Okay. And the x is the ball's horizontal distance in feet from the point of impact. Okay, pay very close attention here. X is the horizontal distance. F of x is going to be the vertical distance. When you take any x value and plug it back in, you get the vertical height. Okay. So, part A says, what is the maximum height of the punt, and then how far from the point of impact does this occur? So basically, you guys, this question is asking you to find the vertex. So for part A, all they really want is the vertex. So this is the part that we're going to write down together for part A. So we know that the value of A in this particular quadratic is negative 0.01. Negative 0.01. The value of B in this quadratic is 1.18. And the value of c in this quadratic is a value of 2. Okay, so if I take negative b over 2a, I get negative 1.18 divided by 2 times negative 0.01. This part you need your calculator for, so let's take our calculators out. Mine happens to be right here. And I'm going to punch in negative 1.18. Please follow along with me, guys. Divided by, I'm going to go parentheses 2 times negative 0.01, close both my sets of parentheses and push enter. And, of course, I get a syntax error. How cool is that? Oh, I have one extra parenthesis there, so I'll get rid of that one. Okay, that should work for me. Hey, there we go, 59. Great. Okay, so this is worth 59. Okay, 59 what? Like 59 monkeys in a tree? Like, what does 59 mean? 59 means that I am exactly at 59 feet away from where the ball is kicked, it will reach its maximum height. Okay, so it says, what is the maximum height and how far from the point of impact does this occur? Well, we actually answered the second part of the question. How far from the point of impact does this occur? Well, it occurs 59 feet away. To actually figure out how tall it is, you have to take 59 and substitute it back in. So we want f of 59, okay? So it's going to be negative 0.01 times 59 squared plus 1.18 times 59, and then we're going to add 2. So we need to do all that in our calculators. So let's bring out the calculators again. And here's mine. And I'm going to go negative 1.18 times 59 quantity squared. And then I'm going to go plus 1.18 and multiply it by 59. And then I'm going to add 2. Okay, then when I push enter on this, I get some crazy number. Hold on one second. Hey, why don't you guys tell me it should be negative 0.01? Okay, my bad. So let's go second entry. And let's go back over here and change this to negative 0.01. Cool. Slow, negative, oh, almost there. Okay, negative 0.0, and then change this to a 1. And now push enter. Hey, there we go, 36.81. That makes a whole lot more sense. Okay, so 36.81 feet high, okay? So what is the maximum height and how far? So the maximum height that the kicker kicks this ball is 36.81 feet high, and it occurs 59 feet away when the kicker kicks the ball. Okay, so for part B, it's asking you how far must the nearest defensive player, who is 6 feet tall from the kicker's point of impact, reach in order to block the punt. So in this picture here, basically, they want to know like how high is this point right here. My guess is it's more than 8 feet, but smaller than 9 feet. So it's 6 feet away, right? How far does this guy have to jump in order to block this football? That's what we want to know. So the best way to do this, you guys, is to take the quadratic that they give to us and plug it into our calculator. And from here, look at the table when x is equal to 6, because he's 6 feet away from the player kicking the ball. So we're going to go second and then go to table. And notice that my x values are all over the place here. So if I go second table setup, I can start my table at 6 and be good to go. And then change my table increments to 1, but that's not really a big deal. So when I go back to the table now, notice I have it 6 and I have 8.72, and that was pretty close to my guess because I said it had to be, just a little bit less than 9 but more than 8. So he needs to be 8.72 feet tall. So basically all I have to do is plug in a 6 and get the answer. So for part B, I would use the calculator and I would figure out f of 6, and the calculator needs to be approximately 8.72 feet tall. If I did that right, I have a bad memory. 8.72, yes, there you go. So that's how you answer part B, and these are the types of problems that you can expect to be able to analyze in class next time we meet. Okay, you knew it was coming. Here's a you try, box number 2. You don't need to copy down the question, just figure out the answer. It says, an archer's arrow follows a parabolic path. The height of the arrow, f of x, in feet, can be modeled by negative 0.005x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. So you guys, this is the exact same setup as box number 1 with the football, except now we're shooting arrows instead. Here's the question. What is the maximum height, and how far from its release does this occur? Okay, hopefully you got the right answer. So what I did was I plugged the equation to fluid math and I got the actual path of the arrow, which is pretty darn cool. And the question says, how high does the arrow go, the maximum height, and when does it happen? So the maximum height that the arrow reaches is 205 feet tall, which you can see in this picture. It's just over 200. And it happens at exactly 200 feet away from when the person fires the arrow. So at 200 feet away, the max height will be 205.